How was your weekend?
Good.
Terrible.
Yeah.
Terrible.
Cleaning the whole weekend.
The whole weekend, that's good, productive.
Virgin Greg, that
I did.
Oh, it's last week's.
Oh. Whoa, was that like more?
For some reason, like,
Ready?
Yes. 13 pages in
I know, it's tough to be back after a 3-day week. 3 weekends. Alright, okay, so let's get back into this. I have 2 inequalities here, and you are to make a graph that represents the solution set for each problem. So what does the solution set look like for x less than 3? And then what does it look like for absolute value of x is less than 3? You guys remember that exercise we did on Friday where we had the human graph? And we saw like what it looks like for absolute values. We not only had some positive solutions, but we had some negative solutions because their absolute values were positive when you take them. So anybody want to show what that might look like?
What?
What the graphs might look like, the solution set?
Just like,
Just like a graph.
yeah.
Okay. All right, so here's a line. This is gonna start our number line, right? So she knows right away that we're comparing all numbers to 3. So open circle or closed circle?
Open.
Good. That means we don't include 3 in our solution set, and what's this say? All values,
Greater than 9. So it's gonna go right.
this says x is less than 3. That alligator eats the bigger meal is 3. So which way does our arrow go?
Left.
All the things to the left. Good. So that is what our inequality, remember we have more than one solution. Then on Friday, we started talking about absolute value inequalities. So what does the graph of this one look like? You guys remember? No? Okay, it's been a long 3 days. So we have that the distance from x to 0 is 3. Does that help remind you? So here's 0. What number are we going to drop first? 3. Yeah. Good. So if the distance between x and 3 is less than 3, where are all the solutions here? Open circle or closed circle? Open, good. And where is the distance less than 3? To the left. So all of these right here between 3 and 0 can be solutions. Good. All right, is that all that can work for absolute values? What else can work? You guys remember about absolute values? Where else is the distance of 3 to 0?
negative.
Negative 3. There you guys, you're waking up, good. Okay, open or closed? Open. And then because we take the absolute value, this becomes positive 3. That's the distance. Where else is it gonna be less than 3? Anything bigger than negative 3. Good. Okay, so now that we have what the solution set looks like for both of these, you see the only difference there in the symbols is that absolute value sign, but what is the same between these two graphs? What's the same?
They both use 3.
They both are comparing solutions to 3. Good. How does their graph look?
One goes right. Oh no, one goes left and then one's like joined together.
Right. So we kind of have some bounds on the distance one. Good. That's kind of like two inequalities, right? What were those called? When we have more than one inequality? Start with a C. Compound, yes. So we have two inequalities, and anytime we have more than one inequality, that's like a compound inequality. Good, so how are these two different from each other? How are the two solutions that's different from each other? Yeah, so she's saying, okay, so the obvious thing is one has those absolute value signs, and absolute value means the distance. Good, and so how does that play out in the graph, like in the solution set? So if I were to extend this out, how far could we go? As far as we want, all the way into negative infinity, right? This just keeps going, and we say that this is everything less than 3. What about over here? That's not the same. So what's different is we're talking about a distance, and we're saying it has to be within 3. So whether x is positive 3 or x is bigger than negative 3, those distances have to be within 3 away from 0. Okay, so kind of going over this and recognizing what's similar, what's different, what do you guys wonder about this? Nothing? Why do we need it? Where can we use it?
Just don't get how we use this in the real world.
Anybody else?
Is it gonna get easier?
What's that?
Is it gonna get easier?
Will it get easier than this?
Yeah.
Okay, so the questions were, when or how are we ever going to use this? And this seems pretty hard. Does it get any easier? So, and we've been doing this far because you guys have done so much work up to this point. So we started out in chapter 1 when we were using equations. So these were with the equal signs, and that is a statement of equality. So when we solve for stuff, we're saying that x, or our solution, is exactly 2. Even when we put those absolute value signs on there, we're saying that the distance is exactly 2, whether it's in the positive direction or the negative direction, but everything is equals. So when we started into chapter 2, then we started introducing, well, what if we have more than one solution? We have many solutions, in fact. So we have to use these symbols that help compare to a solution. So if we have x is less than 2, we're comparing all of our solutions to the number 2, and we're saying as long as it's less than 2, it's going to work. It's going to make our inequality true. Then we got into absolute value inequalities. That's where we are right now. So in real life, we sometimes have an acceptable range for a solution set. And we need ways to express this mathematically. So you guys started on things like this earlier in the chapter where we were like, oh, we know how to do this, we know how to do that, but we don't know how to represent this mathematically. How do we do that? So this is going to give us those tools, especially when the solution is a distance away from the perfect answer. So what if we know what the answer should be around, but we're going to be forgiving and say plus or minus? Have you guys ever taken your temperature? What's the normal temperature supposed to be?
Oh, so I don't know.
95.
Close. 98.9, right?
Oh, okay.
That's supposed to be like your regular normal temperature. What happens if you're 98, let's say 99 degrees Fahrenheit? Is it possible to be that and still be healthy? Yeah, what happens if you're 98.7? You're fine, because there's like that little forgiveness, like plus or minus a point of a degree or two, right? That's how real life is. So we need, if this is the way life is, and we want to model this mathematically, so that we can make sure that that thermometer doesn't say fever, go to the hospital, right? You're still good. Then we need ways to mathematically model that. So we're going to start, instead of doing problems, just cranking out, this is the procedure. I wanted to give you a real life example. Okay, so I want you to picture this. A clothing designer is selecting models to walk a runway for her fashion show. The designer prefers models that are no more than 3 inches away from being 5'10". Why do you think that is? So the ideal height for her is 5'10". Why do you think she wants models that are no more than 3 inches away from that?
Because that's too tall.
And what would happen to her clothes? How would they look? They wouldn't fit right. She's going for a certain look, right? She doesn't want a model where all the clothes are gonna drag on the floor. She doesn't want one where they're too tall and maybe the pants are up to the ankles, right? So she's looking for something that is just right for her clothes, and as long as you're within 3 inches away from this height of 5'10", you're good. So 5'10", if you put that all into inches, that's 70 inches. So I want you guys,
That's one tall people.
it's about an inch taller than me. Yeah, so I want you guys first to think about, how do you determine the model's preferred height? How do you determine that? Can you guys reason that? Like, how do you figure out how tall the model needs to be? I know you guys can reason that out, but how could you begin to model this mathematically? And I have a couple questions there for you to think about. Is there more than one solution? Does the model have to be exactly 70 inches? Can there be more than one solution? So go ahead, write down what you guys think. If we want to determine all the heights of the models, what would they be? You can write them out. It's okay to try to figure out an answer for that. Then once you write them out, I want you to think about, how would you represent this mathematically? Okay. I want you guys to pair up with somebody. It can be somebody from across the room. As a matter of fact, I prefer it to be somebody not at your table. So go ahead, get up, make eye contact, high five your partner, and I want you to discuss what you.
Can you just pair me up with someone? I don't know. Or
Right here.
No one?
Right here. Carlos. Xavier's pretty nice. Okay, so go ahead. If we want to determine the model's height, how could we represent this mathematically? I want you guys to start thinking about that. And try to use each other, come up with some thoughts here. Right?
Inches taller than 5'10".
But she's kind of stuck here. She's not sure like where she should go.
I think you can make a number
So,
or line things, you know.
if you were to reason this out, if you have to be 3 away from 70,
Okay. And then
that's okay, you're within 1 inch, right? So write those down.
I don't know how you do this.
Within 3 inches, yeah. It says no more than 3 inches, so 3 inches will
Do
work.
5'10".
So she says 70 all the way up to 73.
plus 3.
Okay, and then what about the other way? What happens if they're a little bit shorter? So that's your minimum, right? Okay, so you can write down like all of these. Good.
More than. Oh wait, didn't she teach us how to do this before?
The numbers.
Yeah. Yeah. What happens if you're like 63.5 inches? Are you still, yeah, absolutely. So you can see that there, you can find that there are solutions, but you need to now try to write them down mathematically. See if there's a way.
I don't know what we're doing.
I tried figuring it out, but it's not working.
Okay, well, so 5'10", and so we just said that 70 inches, so we can have everything in inches.
Yeah.
Okay, so what else will work?
73 inches.
73, so you can write down 70, 73. Mhm. Is that all that will work?
Yeah.
What about if you're just a little shorter?
3 inches under.
Yeah, will that work too?
Yeah. Shoot.
So it would be 3 inches shorter.
Okay, so
3 inches shorter than
then
70?
you can
Mhm.
write down.
Mhm.
60. Why am I putting 80? Oh my God, Celeste, what's wrong with you?
That's a tall woman.
80 inches?
Yes, so she's saying, okay, so this is gonna work and this is gonna work. And is there a way that you can visualize this besides writing this range?
You can make a
Graph?
Yes,
You graph it?
absolutely. What would the graph look like?
a line.
Oh yeah, that's math. You're using a graph.
And then you can put
What would be in the middle?
7.
Mhm. Good. You guys are well on your way, yeah.
And then,
And then whatever's
The biggest and the shortest, yeah, or tallest and shortest, I should say. Good, yeah. Can you include those 2 points on the ends? It says no more than 3 inches. Can it be 3 inches?
What do you mean? Can you be 3 inches?
It says no more than 3 inches away from their ideal height.
Oh. Yeah.
Yeah, so would that be an open circle or a closed circle?
Open? It's closed?
If it can include
If it can
70.
include, it'll be closed.
Yes,
So closed on 70?
yep.
So. And then.
what did they all connect to each other?
Mhm. Good. So you guys have a graph. I want you to think about how you express that mathematically, like with symbols.
We just.
Yes, perfect. Perfect. So now that we're kind of working in this direction, like how do you come up with some sort of expression that can tell us that?
Yeah.
You guys are well on your
So it
way.
would be the
Good job.
distance between close circle.
Good. You guys are getting this. So she started this number line here, and she's saying anywhere between 67 and 73 is going to work. That's part of the solution, right? The solution set. Good. So I want you to start thinking mathematically, how do we write this as a mathematical expression? Try to think of all the things that we've done that created that graph and kind of work backwards from that way. How about you guys? Situation. What's that? 5'7" and under. So that will work as a model. So she's looking for models that are about 5'10", but, and what about the other direction? All the way up to 6'7", 5'10", 5'11", 5'12", 6 foot, yeah. So how do you show that? How do you represent that? Or begin to represent that mathematically? Okay, good. You're getting it. And how about you guys? I see you started out here. I see lots of sketches here on height.
Can you see the line part that you did?
Okay, so as more of you are going along and getting this, does anybody want to share what they have so far on heights that'll work? Just that part? You want to go?
So it could be, since it's like 3 less than, it could be like between 67 and 73.
Yeah? So I saw this on lots of your papers, which is absolutely, you've got it. So we have this 70 inches that our models need to be, right? Around there somewhere. And the designer, she's very picky, she wants no more than 3 inches from being 70 inches. So that means our models or that she's gonna be looking at have to be within this range. And then, so they could be 67 inches, they could be 67.5 inches. We can get really, really detailed on what those can be because there can be many different heights, right? Within here. So then I began to see that you guys are starting to graph. This is just a number line, but as soon as I saw these circles start to happen, this means, yeah, we can include this point, we can include that point, and when I saw all these marks start to appear, then I began to see this line show up. So this is kind of like what we've been doing to this point mathematically. We've been solving problems and then coming up with the solution and showing the answers. You guys have this real life example. You're not sure yet how to solve it mathematically, but you can definitely represent the solution for it. So that is fantastic because now we can start to make that connection between the two. So the way that we do this is we're going to be using absolute value inequalities. So the idea here is, do you remember when we covered absolute value, the distance from a number to 0? But we can also put in here the distance between two numbers. And in this case, x is going to be whatever height our model is. What's the perfect height that our designer wants?
70 inches.
Yep, 70 inches. So in this case, we're going to put 70 for 70 inches. And then, since we know that there's more than one solution, what type of mathematical symbol are we going to use to show that? When there's more than one solution. What have we been working with in chapter 2? How do we show that there's more than one solution? What kind of symbol do we use?
The equation in the bottom of the inequality. For the
Well, the inequality, right there. So we have a way to say we want to show that there's more than one solution. In this case, our solution here has to be within some sort of allowed deviation. Deviation means just how much we can go away from something. So what is the allowed deviation here? That the designer told us that we can go 3. So she said, yeah, our models don't have to be exactly 70 inches. It can be a little bit away from each other. Check this out. You guys have just set this up right here. We know that the unknown here is whatever the model's height is. The distance between that and the preferred height or the perfect height has to be less than or equal to 3 inches. Does that make sense? Good. All right, so how do we go about solving this? Any ideas? Should we try? Let's do that so we can see how we get this answer. Because we went backwards. We started here instead of ending there. That's where we've ended for all of our problems. Now we started here. You guys are on the right track. You had lots of tools that you needed, but we weren't here yet, and that's where we are today. We want to make sure we understand what's going on, and this puts context to our absolute value inequalities. So this says x minus 70, or the distance between our model's height and the perfect height has to be less than or equal to 3. So if we look at this, we don't care right now what's in here, but what this absolute value is telling us is that we have to be within 3. So if we do this, a distance of 3, what two numbers do we have to be within? 3 and
Negative.
-3, because the absolute value of -3 is 3. So if I took this and graphed it here, that means everything that we're looking for has to be within that. So if we take this negative case, then right here, the distance between our model's height and the perfect height has to be which way of -3? Which side, left or the right side? This is the left. Remember, less on the left, bigger on the right. So which way of -3 do we have to go? Where our solutions are? To the right. So then this distance here has to be bigger than or equal to -3. And now we have to take care of this positive case. When our difference between our model's height and the perfect height is what compared to +3? Left or right of 3? Which way does our shaded area go? Which way is this? Less than 3, right? Less than or equal to 3. So now we have our two cases to solve for. Again, we're solving for x, what side is it on? The left. Is it by itself? No. What operation is this? Subtraction. So the opposite, we're going to add 70 to both sides to get x by itself. That cancels that out, and then we have x is greater than or equal to, what's 70 minus 3? Yeah, 67. Good. So we have one part of this. Now we have to do the same thing to the other side, which is exactly what we're going to do here. That cancels out. X is less than or equal to, what's 70 plus 3, guys?
73.
Good. Check that out. If we went to graph this, we have the smaller number 67, the bigger number 73. We have both of them closed circles because they can equal them. And everything here has to be bigger than 67, so it's to the right. Everything over here has to be smaller than 67, everything to the left, which if we complete this, we're going to make that connection, everything in between. Does that look like what you guys came up with when you reasoned it? Over here? It's exact match. You guys, instead of working the way that we typically work, you used your reasoning, but our reasoning matched up exactly with our mathematical skills here. We actually can model these types of problems now using absolute value inequalities. Awesome, you guys. Okay, so I want you guys to just quickly within your groups talk about what we just did with absolute value inequalities on this problem. Okay, how did we set that up?
I don't know.
So how did we do this? We just took from our reasoning, right? But weren't sure the way that we would model this mathematically. But once we set it up in this way and found that we're looking for a distance between our model's height and the perfect height, that we can actually represent it with the absolute value sign. And then to give it more than one solution, we used our inequality. And we said it can't be anything more than 3 inches. So once we were able to set that up, then we could use all of the other skills to solve for that here. And we get the same exact solution that we came up with at the beginning. So now you guys are becoming mathematicians. Okay, so now that you've seen what this can be used for, I want you to give this one a try. So here is an absolute value. Yes, you can do this, Carlos. You can do this. Now you see what this can be used for, and we can go about and try to find all the solutions to an absolute value inequality. So what does this say? Guys, what does this say?
1 minus 3, wait, the absolute value of 1 minus 3 is less than 9. Yeah.
Perfect. Jose said this perfectly. The absolute value of y minus 3 is less than 9. Good. What does that mean? Oh my gosh, Carlos. Yes, the distance between y and 3 is less than 9. Does that make sense? Yeah. So now we have to find all the solutions that are going to make this correct. The distance between y and 3 is less than 9. So once again, so you guys can see, so that you guys can see what this is going to look like, I'm going to put here y and y minus 3, I'm sorry, not y. 3 is the one thing that we know. And y is going to be how far away from 3? How far can y be from 3? Take a look at that. 9. So we know it can be 9 away on this side, 9 away on that side. So to solve for this, we're going to set these up. Y minus 3 has to be less than 9 away, right? Distance of 9 away. And y minus 3 also has to be greater than, this is like negative 9 away. It's negative away from y, the opposite direction. So how do you guys solve this? Go ahead and give this a try. We did this just before in the last one. I want you to give it a try, struggle a little.
This isn't answered yet?
No, these take a little bit longer.
I thought this was the answer.
No. You're starting with, I'm glad you're thinking that way. You're starting with the problem now and you're finding the solution. So you want to find something, all the values for y that's going to make this true.
Tired.
So what kind of values would make this true? That's what we're looking for. So we have that absolute value, so that means it's going to be a distance away, and it could be in the positive direction and the negative direction.
No, 6.
Okay. Positive and negative. Okay. Perfect. Good job. Perfect. Do you want to shake work? Okay. Yeah. Okay, so we have Wendy here that has gone through and solved for both cases. You could use it, you can erase it, whatever you'd like. Perfect. Okay, so Wendy, can you do one more thing and put where 3 is in that graph? Yeah, actually, perfect. So Wendy went through just the steps to get y by itself. She added 3 to both sides and got y is less than 12, and then also added 3 to both sides and got y is greater than -6. So if you look at this inequality plotted here, how many away is 12 from 3? 9. Good.
Oh,
Yeah. So that's a check. How many away is -6 from 3? 9. We've got both solutions, so anything that will make this inequality work is going to be, and I mean this absolute value inequality, is going to be any value between -6 and 12, but it cannot equal those. It has to be anything in between those two. All right, show of fingers. How do you guys feel about solving this type of absolute value inequality? Good. Good. All right, so this just takes practice, and we have another day of practice with this. Actually, another 2 more days. So I just wanted today to go with you through an actual real world problem where you would use this type of thing. So hopefully throughout the day today, you can think about how can I use absolute value inequalities to solve real life problems. Anything where you're comparing, you have some sort of perfect measurement and you want something that could be greater than or less than in both directions, and there's more than one solution, you've got an absolute value inequality. So we'll pick up more of these tomorrow. Right now, I want you guys to write this problem down. Again, we saw it on Friday. And then once you have it written down, I want you to discuss with each other what solutions might look like, if there is one.
Just put no solution.
No solution.
Yeah, I got it. Well, is it like that? One.
But why are we supposed to make like
So real quick, on this one, before you go on and set off to solve an absolute value inequality, take a look. If you have the absolute value all by itself on one side, and then you have a negative value on the other, what is that telling you? So, Jose, what does this inequality say?
It says the absolute value of k minus 3 is less than -1.
Okay. The absolute value of k minus 3 is less than -1. What does it mean? Now that we've said it, what does it mean? What does that mean if we put it in words?
Oh.
The distance between k and 3 is what? Less than -1. Do we have any negative distances?
You can't have a negative distance without no solution.
That's right. So then the answer to this is what? No solution. Good job. So make sure that you check these types of things before you go out and solve them. Because even your solution, you get it, should not make any sense. You're saying that the distance between two numbers is a negative, and we don't have negatives in distances. Good job.
She's living her best life.
You have homework tonight. You have homework tomorrow night. And we're just gonna be continuing absolute value inequalities. This is a tough one, you guys. You guys are doing a great job. All right, so you have a few minutes